All right, let's get right into it. You know, we think of our eyes as these simple windows to the world. But what if I told you that sometimes they're hiding one of the body's most dangerous secrets? Today, we're going to unmask a silent, deadly cancer that can grow for decades without you ever feeling a single thing. Yeah, we've all heard that saying, the eyes are the window to the soul. It's poetic, right? But in medicine, the eye's unique design makes it the perfect hiding place for a threat that can just sit there, developing completely under the radar until it's become dangerously advanced. So, where does a story like this even begin? Well, it usually starts with something that looks totally harmless, like a little spot or a freckle. But because of the eye's unique biology, that little spot can quietly transform into a hidden and potentially lethal threat. And look, this is not a cancer that just pops up overnight. Just take a look at this real patient's timeline. For more than 20 years, 23 to be exact, what looked like a simple freckle inside the eye, a choroidal nevus, was silently changing. It's a pretty powerful reminder that these spots, even when they seem fine, have to be monitored for life. They're basically slow-motion time bombs. So why is the eye such a perfect hiding place? It's what doctors call a sanctuary site. Think of it like a fortress, okay? There's this thing called the blood-ocular barrier that protects the eye, which is great. But it also means the body's immune system patrols can't easily get in. And that lets a tumor grow in total isolation, completely shielded from the very systems that would normally find it and destroy it. Okay, so if these little spots can be so sneaky, how in the world do doctors figure out which ones are actually dangerous? Well, it turns out it takes a little bit of detective work, where they're looking for a very specific set of clinical clues. And they have this incredibly powerful mnemonic to help them out. Each letter stands for a high-risk feature. T for thickness over 2 millimeters, F for fluid under the lesion, S for symptoms like vision loss, O for orange pigment on top, M for a special melanoma hollow they can see on an ultrasound, and D for a diameter over 5 millimeters. It's a brilliantly simple, cheap, and really effective way to figure out the danger level. And check this out. This is how those risks stack up. If a spot has 0 of those risk factors, the chance of it turning into cancer is tiny, just 1%. But look what happens if you find just one of them. The risk jumps all the way to 11%. And with 4 or more factors, the odds are suddenly more than 50-50. This is exactly how doctors go from, let's just keep an eye on it, to, okay, we need to act right now. But what if we could spot the danger even sooner, down at the molecular level? Well, that's where the next part of this story comes in, a huge technological breakthrough that's letting doctors find the cancer's hidden fingerprints, even inside a sanctuary site like the eye. The big challenge here is what researchers call the iceberg problem. The tumor is constantly shedding these tiny fragments of its DNA into the bloodstream. But because of that sanctuary barrier, the amount that actually gets into your general circulation is just minuscule. It's like trying to find one specific grain of sand on an entire beach. And this brings up a really fundamental question for doctors, right? You can't just go sticking a needle into the back of someone's eye for a routine check. It's way too risky. So how do you get a sample of a tumor that you can't safely reach? And the answer is the liquid biopsy. But here's the really clever part. Instead of taking blood from your arm, where all that tumor DNA is super diluted, researchers figured out they can sample the fluid from inside the eye, the proximal fluid. In there, the concentration of tumor DNA is literally thousands of times higher. This makes detection incredibly sensitive and basically solves that whole iceberg problem. Now, finding the cancer is one piece of the puzzle, but the deadliest tumors, they do something else. They spread. And to understand how they do that, we have to crack the tumor's genetic code and see how it builds a shield to escape our body's own defenses. And it pretty much all comes down to this one critical gene, BAP1. Think of BAP1 like the brakes on a car. It's a tumor suppressor. When a cancer cell loses both copies of this gene, well, the brakes are gone. This is one of the single strongest signs that a tumor is about to go metastatic and spread all over the body. So how does losing just one gene cause all this chaos? Well, it sets off this really sinister chain reaction. First, the cell loses BAP1. That loss kicks other proteins into overdrive. These proteins then act like spies, and they go out and reprogram the body's own protective immune cells. They basically turn these guards into traitors, who then tell the body's main cancer killers, the T cells, to just stand down. The tumor literally creates its own invisibility cloak. So what this means is that the most aggressive tumors aren't just growing and running away. No, they are masters of disguise. They are actively manipulating the body's immune system to build a fortress for themselves from the inside out.
But here's the good news. By understanding exactly how the enemy hides, scientists can finally figure out how to unmask it. And all of this new knowledge is kicking off a whole new era of treatment, giving us hope where, honestly, there used to be very little.
I mean, just 10 years ago, a list of treatments like this one, it wouldn't have even existed. There were zero trials to stop this cancer from spreading. Today, we have a whole new arsenal targeting tumors of all different sizes, with the goal not just to kill the cancer, but to save the eye, preserve vision, and stop metastasis in its tracks. And the results? They're pretty remarkable. In one trial for large tumors, 57% of patients who had been told they were going to lose their eye were able to save it, all because this new treatment shrank the tumor so effectively.
And get this, for the patients whose tumors responded especially well to the treatment, the eye salvation rate was an incredible 95%. This just shows you the power of these new therapies. We are literally moving from a world of removing eyes to saving them.
And it's not just about saving the eye itself. By shrinking the tumor before radiation, doctors can use a much smaller, more targeted dose. And that has led to a 65% reduction in the risk of severe vision loss. That is a massive leap forward for a patient's quality of life. So we end up right back where we started, with the eye. We've gone from a silent little freckle all the way to cracking a cancer's genetic code. And with these breakthroughs, like the liquid biopsy from the source and these new targeted therapies, you have to ask, are we on the edge of a future where a simple fluid sample could stop these hidden killers before they ever get a chance to spread? The science is telling us we are closer than we've ever been.